हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्स अप? कैसे हैं सब लोग? की हाल चाल? प्लीज गाइस डू join me fast, and those who are already here, let me know through the comment section if I am audible and visible to you all perfectly. Please do let me know if my audio video all are clear so that we can start our session on time. So this is Chandra Shekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. And you guys are watching me live through the beautiful series for BARC and HAL Aspirants, that is Atomic series, and today is our second session for Thermodynamics part 2. Please do let me know if my audio video are clear or not. Can you guys hear me? Yes. Shall we start our session? This is the complete numerical practice session, and through the numericals practice only, we will be revising, we will be understanding the related concept of second law and entropy. I'm not able to see your comments. Please mark your presence by writing in the comment section. Everyone, please do let me know if you are ready to explore the beautiful session on basic thermodynamics, that is part 2, second law and entropy. This is my quick introduction. Those who are meeting me for the first time, I am mechanical engineering graduate from IIT Delhi and also cleared engineering services examination in 2009. I have worked in SAIL for a couple of years, and I have also worked in a private consulting firm for more than 2 years. And from last 9+ years, I am into teaching, guiding the students who are preparing for various competitive examinations. And I am quite comfortable in these many subjects of mechanical engineering. Fluid mechanics, heat transfer, thermal and industrial engineering are my preferred subjects to teach. All right. There is a problem with the chat. Let me see. Am I audible? Am I audible to everyone? Can you guys hear me? Do write in the comment section. Okay. Those who are here on this platform for the first time, do not forget to like, share and subscribe this BYJU'S YouTube channel. There are 2 YouTube channels. One is for English students or English speaking students, and the other one is completely dedicated to Hindi audience. So do like and subscribe these channels. Hi Sai Kumar, good afternoon, good evening, welcome to the session. So let us start the session. But there is a quick announcement before we proceed to discuss the numericals. Please keep your pen, notebook and calculator handy so that you should be able to solve the numericals. You should be able to solve the question, and then you will develop the confidence, and you will get to know your weak areas so that you can improve them further. Good afternoon, Sai. Welcome. So there is a session on 13th of March by your favorite Abhinav Negi sir on the strategy to crack GATE 2023. Those who are preparing for 23 examination, they must join this session on YouTube channel for getting the complete detailed strategy to improve your performance in GATE 2023 examination. Everything will be discussed in detail in that session. And today I will be meeting you again at 8 p.m. in the evening at 8 p.m. we have started a new series for GATE 23 aspirants, that is Mastering Concepts for GATE 23. So here in these sessions, we are having the concept clarity, complete conceptual clarity, as well as numerical practice sessions. So complete package will be provided to you free of cost on the YouTube platform. All right. Yes, this is about the thermodynamics, Divana Mastana. This is for thermodynamics. So yes, you can, if you have studied thermodynamics, if you want to explore the concept of thermodynamics, if you want to improve your concept of thermodynamics, you must join this session. All right. Let us start. There is a first question on the screen. I have brought around 15-16 questions in today's session. All are from Entropy, Second Law of Thermodynamics. So there is the first question on the screen. Can you just solve it and let me know the answer? Everyone, please guys, do let me know your answer through the comment section. There is a Carnot refrigerator. What is Carnot refrigerator? It is the reversible refrigerator operating between -1 degree Celsius and 33 degrees Celsius. T2 is equal to -1 degree Celsius. There is a refrigerator. Work input is W, and this is higher temperature, that is 33 degrees Celsius. Have a cooling capacity. Let me call Q2, then this is Q1. What is cooling capacity? That is the refrigeration effect of 1.6 kilowatt. It is refrigeration effect. Q2 is 1.6 kilowatt. The power consumed by the refrigerator is. Can you let me know what is the power consumed by the refrigerator? So W is to be calculated. Good afternoon, Robin. Welcome to the session. There is a question on the screen. Can you just solve it and let me know the answer quickly? Everyone, please do solve it. Because it is a reversible refrigerator, COP is desired effect upon work input. So that is Q2 by W, or we can write it as, because it is a reversible refrigerator. So we can write it in terms of temperatures T1 and T2. We can equate. This is the expression for COP for reversible as well as irreversible cycle. But this expression is completely applicable to reversible cycle. T1 upon T1 minus T2. What is the answer? Pawan is saying B, Sai is saying C. What is the correct one? Q2 is 1.6. The question is to find out the power consumed. So we can say W is equal to Q2 into T1 minus T2 upon T1. Put the value, you will get the answer. Q2 is 1.6 kilowatt. T1 minus T2 is equal to 34. Isn't it 34? 34. The difference is because it is the T2 temperature is negative, -1 degree Celsius. So 33 minus -1 is 34 divided by T1. T1 must be in Kelvin. The temperature has to be absolute temperature. As long as we are talking about the temperature difference, you can either calculate in degree Celsius or Kelvin, will give you the same result. Temperature difference will give you the same result, but when we are writing T1, then it must be 273 plus 33. That is where people commit mistake. So whenever I am writing the temperature difference, it is 34, whether you find the difference in Kelvin or Celsius. So that will give you the answer C. C is the correct answer. That will give you option C. Are you getting option C or not? Pawan, please check your calculation. Option C is the right answer. Robin, one more session will be there for application day after tomorrow. And then we will be starting. This is for BARC. There are two parallel series which are running. One is BARC and HL. So one session for thermodynamics I have already taken. This is the second session, and there will be one more practice session for application of thermodynamics, applied thermodynamics. All right. And from today, we have started the another series for 23 aspirants, and then it will have around total 10 sessions will be there. Around 5 sessions will be theoretical, that is conceptual, and the remaining 5 will be numerical practice session. So from today there will be 10, today onwards there will be 10 more sessions, but the timing for that mastering gate 23 is 8 p.m. in the evening. All right, is this clear? Sai, what is that? Is there any confusion, Sai? Sorry, yes. It should be T2 upon T1 minus T2. Definitely it is T2. It is T2 and it will be 273 minus 1, isn't it? Yes, it will be 272. Correct. Then we will get option C, right? कैप्टन अजय, क्योंकि ये YouTube सेशन है, ये ऐप पे नहीं चल रहा है, इट इज रनिंग ऑन YouTube प्लेटफॉर्म, इसलिए आप YouTube बायजूस YouTube चैनल को ज्वाइन करिए, सब्सक्राइब करिए, देन you will be getting this session. The next question number 2, the next one, the next question number 2 on your screen. Very simple, very easy, but yes, these type of questions are also important from your competitive examination point of view. On a TS diagram, the slope of constant volume line, if I draw TS diagram, this is entropy on x-axis, temperature on y-axis. This is how the diagrams will be drawn, like this. So constant volume will be having more slope, constant pressure will be having less slope. So dt by ds for constant volume is T by Cp, and dt by ds for constant pressure is T by Cp. And because Cp is greater than Cv, or we can say Cp by Cv is equal to gamma, which is greater than 1, then we can say slope of constant volume is equal to gamma times slope of constant pressure process. So we can say gamma is greater than 1. So constant volume lines will have more slope than constant pressure line. Anjali, it is not A. It is option B. Constant volume will have more slope compared to constant pressure. This is how we can write the slope on TS diagram. Can you just let me know isothermal and adiabatic, which will be having more slope? Is it isothermal or adiabatic process on PV curve? On PV curve, if I ask you on PV curve, which is having more slope, isothermal or adiabatic? dt, sorry, on PV curve, dp by dv for isothermal is equal to minus p by v, and dp by dv for adiabatic, slope is negative, is equal to gamma times minus p by v. So adiabatic process will have more slope than isothermal on PV curve. So slope of adiabatic process will be more than slope of isothermal on PV curve. But on TS diagram, the slope of constant volume process will be more than the constant pressure process. Let us move to the next one. Yes, let us move to the next one. How to draw? Can you just let me know how to draw isothermal and adiabatic process on PV curve? They will be like this. This is adiabatic. This is adiabatic, and the other one is isothermal. This is isothermal. on PV curve. So you must know the relation between the slope of these curves on PV diagram as well as TS diagram. Next question on the screen. The next one. Yes, Rowan, very nice. Please try the next one then. Atmospheric air whose specific gas constant is 287 joule per kg Kelvin. Kelvin is missing. Gamma is 1.4 at 1 bar. The pressure P1 is 1 bar and the temperature T1 is 25 degrees Celsius is compressed adiabatically. It is adiabatic compression to 2 bar. P2 is equal to 2 bar and temperature T2 is 105 degrees Celsius. Which one of the following statement is correct? Is the process possible or impossible? And if it is possible, will it be reversible or irreversible? Don't you think that option B and option D are same? Don't you think option B and option D are same? When the process is possible and reversible, reversible adiabatic process is always isentropic. Reversible adiabatic is always isentropic. Reversible adiabatic is always isentropic. But is it reversible adiabatic or irreversible adiabatic? It is only adiabatic given. Adiabatic means Q is equal to 0. Will it be reversible adiabatic or irreversible adiabatic? Yes, I am waiting for your response. So from the twin equation TdS is equal to dH minus VdP. Do you remember this expression? Or we can say ds is equal to dH by T minus V by T into dP, and PV is equal to RT. V is the specific volume. V is the specific volume. So and dH can be written because it can be treated as ideal gas. So dH is equal to Cp dt by T minus what is V by T? R by P into dP. And if we integrate, then we will get delta S is equal to Cp ln of T2 by T1 minus R ln of P2 by P1. That will be the change in entropy of the system. That will give you the change in entropy of the system. Isn't it? That will be the change in entropy of the system. What is Cp? It is atmospheric air. Gamma is given, R is given. R is 287, gamma is 1.4. So Cp will be equal to 1005 ln of T2 by T1. Don't forget to convert them in Kelvin. Plus 273. So what it will be? 105 plus 273 upon 25 plus 273 minus R 287 ln of final pressure upon initial pressure, that is by 1 ln 2. What is the value delta S for the system? What is the change in entropy for the system? The change in entropy for the system, are you getting 40 joule per kg Kelvin change in specific entropy? Are you getting 40 joule per kg Kelvin or not? And what is the change in entropy for the surrounding? That is equal to 0 because there is no heat loss to the surrounding. Q is equal to 0. So the entropy change for the surrounding is equal to 0 and entropy change for the system is plus 40. So change in entropy for the universe will decide change in entropy for the system plus change in entropy for the surrounding. That will decide whether the process is reversible or irreversible. If change in entropy for the universe is greater than 0, then the process is irreversible. If the change in entropy is equal to 0, then it is reversible process, and if it is less than 0, then it is impossible. The process is not possible for which change in entropy for the universe is less than 0. So entropy of universe never decreases. That is called as principle of increase in entropy of universe. That is called as principle of increase in entropy of universe. Because it is greater than 0, because it is greater than 0, so the process is irreversible and possible. Because it is greater than 0, the process is irreversible and possible. Option A is the right answer. Option A is the correct answer, isn't it? So don't think that because it is adiabatic given means isentropic. Adiabatic is not isentropic. It is always reversible adiabatic which is isentropic. Reversible adiabatic is isentropic. Don't think that adiabatic process is given so we can say it is isentropic. No. Only reversible adiabatic process is called as isentropic. I hope it is clear to everyone. This expression is valid for reversible as well as irreversible process. This is valid for reversible as well as irreversible. We do not know whether the process is reversible or irreversible. We can find out the change in entropy for the system, change in entropy for the surrounding, and then we can calculate the change in entropy for the universe, and we can decide whether the process will be possible or impossible. Next one, question number 4. Is this clear to everyone? Please make some noise. At 8 p.m. we are meeting again on the same platform, BYJU'S English YouTube channel. Do join me. I will discuss the complete strategy how to prepare thermodynamics for your GATE examination. The next question on the screen. The question is about quality, or we can call it as dryness fraction. The question is about the dryness fraction. X. A pressure cooker contains saturated water vapor mixture at 100 degrees Celsius with a volume of vapor being 8 times that of volume of liquid. Volume of vapor is equal to 8 times of volume of liquid. That is given. The specific volume of saturated liquid, either we write VF or VL, one and the same thing, VF is equal to 0.001044, and V vapor or VG is equal to 1.6729 meter cube per kg. What will be the dryness fraction? What is the formula for dryness fraction? What is dryness fraction? That is the ratio of mass of vapor to the total mass of the mixture. Mass of liquid plus mass of vapor. That will be the dryness fraction. Can you find out the dryness fraction for this? Can you find out the dryness fraction? What is specific volume? What is specific volume? Specific volume is volume per unit mass, isn't it? Yes, Anurag. Can you solve it? What is specific volume of liquid? We can say volume of liquid upon mass of liquid, volume per unit mass. Similarly, specific volume of vapor is volume of vapor upon mass of vapor. So if I want mass of liquid and mass of vapor, what is mass of liquid and mass of vapor? What is mass of vapor? Can we say mass of vapor upon mass of liquid plus mass of vapor? Can we say mass of vapor is equal to volume of vapor upon Vg? And what is mass of liquid? That is volume of liquid upon VL plus mass of vapor, volume of vapor upon Vv, or specific volume of vapor. Now volume of vapor is 8 times the volume of liquid. That is also given. So if we put volume of vapor as 8 of volume of liquid, we can say it is 8 VL upon VV upon, this is already VL upon VL plus again VV is 8 VL upon VV. If you take VL common, it will get cancelled out. So the dryness fraction is given by 8 by VV upon 1 by VL plus 8 by VV. These are specific volume of vapor. This and this is called as specific volume of liquid. Specific volume of vapor and specific volume of liquid. Can you let me know the answer? Can you solve it? Specific volumes are already given. Put the values. This is for liquid and this is for vapor. What is the answer? If you put the values, 8 divided by 1.6729 upon 1 upon 0.001044 plus 8 by 1.6729. That will give you the answer. That will be the answer. So it will be around, are you getting 4.967 into 10 to the power minus 3. It is around 0.005. Are you getting 0.005? It is around 5 into 10 to the power minus 3. 5 into 10 to the power minus 3 is 0.005. Are you getting option A or not? Anurag, are you getting option D? The D you are getting. Isn't it option A? Yes, Manas. Good, good, good. Is this clear to everyone? The dryness fraction is the ratio of mass of vapor to the total mass of the mixture. That is sum of mass of liquid and mass of vapor. And we can write this expression in terms of specific volume of liquid and specific volume of vapor. Because the specific volume is volume per unit mass. Right? Time. Are you getting 49.6? 0.005. Option A is the right answer. Next one. Next question. There is a heat engine, work producing cyclic device. E1 operates between an infinite reservoir at 800 degrees Celsius. This is 800 degrees Celsius. This is E1 and a body B. This is, let us say, body B. The temperature of the body B remains constant at 550 degrees Celsius. Read the question and draw the diagram. Heat transfer to the engine E1 is 900 kilojoule. Q1 is equal to 900 kilojoule. 900 kilojoule. And the work output is W1 is equal to 200 kilojoule. Another engine E2 operate between the body B. This is another engine operate between the body B and the atmosphere at 27 degrees Celsius. This is 27 degrees. They are not reversible engines. It is not mentioned that they are reversible. Heat engine. Now, because the temperature of body B remains constant at 550 degrees Celsius, what does that mean? Whatever the heat added to the body B is equal to heat removed from body B. Q2 will be same. This and this will be same because the temperature will be constant. TB is equal to constant. Heat rejected to the atmosphere, that is 350 kilojoule. The thermal efficiency of engine 2 is. What is the value? What is the thermal efficiency of engine 2? This is how the diagram will be drawn. This is how the diagram will be drawn. What is the thermal efficiency of engine 2? The work output by the engine 2 upon heat input to the engine 2, that will give you the answer. W2 by Q2. So first of all, using the first law of thermodynamics, can you find out Q2? 900 is heat input and work output is 200, so it will be 700 kilojoule. This will also be 700 kilojoule, and because 350 is heat rejected, so W2 will be equal to 350 kilojoule. It is from the first law of thermodynamics applied to the cyclic devices. Net heat transfer is equal to net work transfer for a thermodynamic cycle. So W2 will be equal to 350 and Q2 will be equal to 700, that is 0.5. Right? Fifth question, answer to fifth question is B. Yes, Anurag. Well done. Shall we proceed further to the next one? Question number 6 on your screen. Already, I want everyone to solve. An engine, again there is an engine. Work producing cyclic device, clockwise cycle. Reversibly receives 1200 joule of heat at 900 Kelvin. This is 900 Kelvin. It is receiving 1200 kilojoule. Sorry, 1200 joule. The Q1 is 1200. After rejecting heat to the ambient at 300 Kelvin, it develops 600 joule of work. The irreversibility is equal to, is it option D? Irreversibility. Can you find out the irreversibility? What is irreversibility? Irreversibility is T naught into delta S for universe, or that is entropy generation. T naught into delta S of universe. Can you find out the irreversibility? So we can treat this system as isolated system. This is our isolated system. This is isolated system. The system is isolated. Only work is produced by the system, so the work does not carry entropy. That is why it is isolated system. So how to calculate the change in entropy? So change in entropy for one, we can say irreversibility is T naught into delta S1 plus delta S2. That is 1, that is reservoir 1 and reservoir 2. There is no change in entropy for the working fluid. T naught is 300 Kelvin, that is the ambient temperature, 300 Kelvin. Then there is a decrease in entropy for the reservoir 1 source because the heat is rejected. So we can say minus Q1 by T1 plus there is a heat added to the reservoir 2, so plus Q2 by T2. T2 is equal to T naught. So that will give you the answer, irreversibility. The unit of irreversibility is joule per Kelvin. Irreversibility, sorry, in joule. Irreversibility is in joule. So 300 into minus 1200 by 900 plus what is Q2? From the first law of thermodynamics, Q2 will also become 600 joule. So 600 by 300 will give you the answer. Irreversibility. It will not be 0 because the engine is not reversible engine. The heat addition is reversible process, but the engine is not a reversible engine. The cycle is not reversible. That is why there is irreversibility associated. Can you solve it and let me know the answer? Are you getting 200 joule irreversibility? Option C. Are you guys getting option C? Yes, Anurag, Manas, Satya. Very good. Option C is the correct one. Then there is a common data question for question number 7 and 8. Saturated water vapor enters an adiabatic turbine. Adiabatic means there is no heat transfer. Adiabatic means insulated turbine. There is a difference between insulated and isolated. Insulated means there is no heat transfer taking place at 0.8 megapascal and leaves at 0.1 megapascal. These are the pressures before entering into turbine and after leaving from the turbine. The mass flow rate of water vapor is 25 kg per second. Use the following data table to answer the question 7 and question 8. So shall I show you the question number 7? Quality of steam at the exit of the turbine after isentropic expansion is. What is the value of X when expansion is isentropic? If I draw TS diagram, it is the saturated water vapor which is entering into the turbine. So the curve will be like this. This is 0.1 and it is like this isentropic. This is 0.2. What is the value of X2? That is the question. What is the value of X2? These are constant pressure lines. These are constants. This is 0.8 megapascal and this is 0.1 megapascal. 0.1. Can you find out the dryness fraction using this table? Can you find out the quality of steam? Can you solve it? As S1 is equal to S2 because the process is isentropic. What is S1? S1 will be equal to Sg. That is S1. S1 is Sg in kilojoule per kg Kelvin. So 6.6628 is equal to what is S2? S2 can be written as that is corresponding to 0.1 megapascal. That is SF. This is S2 will be equal to SF plus X2 into SFG. So that is how we can get the value. So that is SF will be equal to 1.3026 corresponding to 0.1 megapascal plus X2 that is unknown and SFG is Sg minus SF 7.3594 minus 1.3026 will give you the value of X2. What is the answer to X2? What is the value of X2? Value of X2? Can you find out the answer? Are you getting x2 as 0.88? x2 will be equal to 0.88. Option C is the correct answer. Option C, yes, Satya. Manas, good, 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 Anurag. Well done, keep it up. That is the first part, and the second part of the question is, if the steam leaves the turbine as saturated vapor, it means x2 is equal to 1. If the steam leaves the turbine as saturated vapor, the power produced by the turbine in kilowatt is. What will be the power produced by the turbine in kilowatt? X1 is also 1, x2 is also equal to 1. Then what will be the power produced? Can you find out the power produced by the turbine? Question number 8. This is, we can say, the power produced will be equal to, because there is no heat transfer from the steady flow energy equation, we can say Q is equal to W plus delta H. There is no change in potential energy, there is no change in kinetic energy, is equal to 0. Q is equal to 0. So we can say W is equal to H1 minus H2. H1 minus H2. That is how the power produced can be calculated. What is H1? H1 will be equal to this Hg. H1 will be equal to Hg at 0.8 megapascal. That is 2769.10. What is H2? Because it is leaving the turbine as saturated vapor only. H2 will be equal to 2675. Hg at 0.1, 2675.5. So subtraction of this 2 will give the what? In kilojoule per kg. Okay. We need to find out in mass flow rate is also given. So we need to find out in kilowatt. So in kilowatt it will be W dot is equal to mass flow rate into H1 minus H2 in kilowatt. We need to multiply with the mass flow rate also. We need to multiply with mass flow rate as well. So it is 2769.1 minus 2675.5. That will give you the answer. What is the answer? For the second part, are you getting option C again? 7th and 8th both will have C option as the correct answer. Question number 9. Next one. Question number 9. Everyone please let me know the answer through the comment section. A heat pump which operates in a cycle extracts heat energy from the cold reservoir. This is Q2. And supplies the same amount of energy to the hot reservoir. It is same Q2. This is T1. This is T2. So we can say work is equal to 0. From the first law of thermodynamics, Whatever the energy entering is equal to energy leaving, so work will be equal to 0. Which one of the following statements holds for this process? First law is not getting violated. The first law is not getting violated, but yes, it violates the second law of thermodynamics, or it violates Clausius statement. Violates Clausius statement of second law. Without any external support, it is impossible to move the heat from low temperature to high temperature reservoir. It is violating the Clausius statement of second law. So this process violates the second law, but not the first law. Option C, yes. Ninth option C is the correct answer. Question number 10. Question number 10 on your screen. An insulated rigid container having 1 meter cube volume has 2 compartments having equal volume. It is insulated and rigid container. The total volume is 1 meter cube, but there are, so this is 0.5 meter cube. This is also 0.5 meter cube. Equal volume, separated by a thin membrane. Half of the container is filled with helium. There is a helium in one part. Specific heat, this gas constant is given. Cp, Cv are also given, while the remaining half is empty. There is vacuum in the remaining half. Suddenly the membrane ruptures and helium fills the whole volume of the container. Temperature and pressure of helium before rupture are T1 is equal to 500 degrees Celsius and P1 is equal to 0.1 megapascal. The change in entropy of the helium is, so it is free expansion. Isn't it free expansion? It is a case of free expansion. What is the answer? Question number 10. Have you solved it? So it is a free expansion. And for free expansion, U1 is equal to U2 first law. When it is free expansion, Q is equal to W plus delta U. Q is equal to 0, insulated. W is equal to 0, rigid. So delta U is equal to 0, U1 is equal to U2. And if it is an ideal gas, so T1 is equal to T2. Because for ideal gas temperature, U is a function of temperature only. U is a function of temperature only. So if we write TdS is equal to du plus Pdv, that will give you the value of change in entropy. So this will become 0. So we can say ds is equal to P by T into dV. Or we can say change in entropy is equal to, the question is to find out the change in entropy in kilojoule per Kelvin. We need to have the mass flow rate also. Delta S is equal to PV is equal to MRT. So we can say P by T is equal to MR by V. The unit will be joule per Kelvin. This is capital S. Or we can say delta S for the system will be equal to M into R into ln of final volume by initial volume. And M into R can be written as P1 V1 upon T1 into ln of final volume by initial volume. That is change in entropy for the system. It is free expansion which is irreversible. Free expansion is irreversible. So this will give you the answer. Can you put the values and solve it? P1 V1 upon T1 into ln of Vf by V initial. So change in entropy will be equal to 0.1 into 10 to the power 3, because I want in kilojoule. P1 into V1 initial volume 0.5 upon T1. T1 is 500 degrees Celsius, so it is 500 plus 273 into ln of the final volume is 1 upon 0.5. That will give you the answer. That is the change in entropy of helium. And that is the change in entropy for the universe, because there is no change in entropy for the surrounding. That is equal to 0. Entropy change for the surrounding will be equal to 0. And that is why that will give you the total entropy change for the universe. And that is why, because it is positive, it is irreversible process. Free expansion is irreversible. What is the answer you are getting? Question number 10. Are you getting option B? 0.0448 kilojoule per Kelvin. The unit conversion is very, very important. Where to multiply with mass flow rate? If I talk about the specific entropy, that is joule per kg Kelvin. But if I write total entropy, that is joule per Kelvin. That is mass into specific entropy. The next one. The next question. Do you remember Maxwell relations? Do you remember Maxwell relation 4 equation? Theoretical question can be framed from that portion. What is the answer to question number 11? Do you know? You can memorize the Maxwell relationship by using this, by having this short trick, or by using the thermodynamic square. Are you having an idea about thermodynamic square? Good. Forgot the shortcut to remember. Generally, people make the shortcut to remember, but yes, there is a possibility you might forget the shortcut even. Good professors have studied under very fine teachers. Good professors have studied under very fine teachers. If you remember this statement, then you can develop the Maxwell relationship. And there is a note here: if S and P are coming together, then put negative sign. So let me check your memory. What is the answer to question number 11? What is the correct answer to question number 11? If S and P are coming together, put negative sign. Now draw the thermodynamic square. This is the thermodynamic square, let us say. This is the thermodynamic square. Start from here. Good professors have studied under very fine teachers. First write this: del T by del V at constant entropy is equal to del P by del S at constant volume. Because there is S and P coming together, there is a negative sign. Then write this. This is one equation. Then we can say del V by del T at constant pressure is equal to del S by del P at constant temperature. Again there is a there is S and P coming together, then there is a negative sign here also. This is 2. Then you can write this del T by del P at constant entropy is equal to del V by del S at constant pressure. This is 3. And the fourth one is like this. So it is del P by del T at constant volume is equal to del S by del V at constant temperature. This is 4. So which is, it is del P by del T at constant entropy. It is del T by del P at constant entropy. It is from this. Del P by del T. So from here what we can write, del P by del T at constant entropy is equal to del S by del V at constant pressure, isn't it? Del P by del T at constant entropy is equal to del S by del V at constant pressure. Isn't it option A? Isn't it option A? Option A is the correct one. Are you getting it? So that is the shortcut to memorize the Maxwell equations. There is a high possibility that any theoretical question can be framed from the Maxwell equation. The next question number 12. Call the next one. The last question for the day. And day after tomorrow we will be meeting again at the same time 4 p.m. for practicing the numericals from the topic applied thermodynamics or applications of thermodynamics. Alright, and tonight at 8 p.m. Tonight at 8 p.m. do not forget to join me for the complete strategy of preparation strategy for thermodynamics on YouTube channel. Ask your friends also to be part of that session. What is the answer to this question? A rigid spherical vessel contains 1 kilogram of wet steam of quality X at a pressure P1. This is shown by point A on TV diagram. Heat is transferred to the vessel to form superheated steam at pressure P2. The temperature T2 is shown by point B. B is in superheated region, A is in wet region. Specific enthalpy and specific internal energy corresponding to saturated water and saturated vapor at P1 and P2 as well as at point A and B are given. What is the correct answer to this question? The question is heat transfer to the steam is very simple. The heat transfer to the steam, because it is steady flow device, steady flow energy equation, we can say Q is equal to delta H plus W. There is no work done. So Q is equal to delta H. So Q is equal to HB minus HA, isn't it? And per unit mass, it is small hb minus small ha. Option A is the correct answer. The question looks lengthy. The question, sometimes you can find the questions in such a manner that they might look lengthy when you read the question, but the solution might be so simple. So do not get disappointed when you are getting lengthy question. Have a look, try to understand the question. Then there is a possibility that the answer will be in one line only. So that is how the questions are framed, to pressurize you, to make you uncomfortable. When you read the question, you start having the feeling that the question might be tough. All right. These are some assignment questions. Try to solve these questions at home, and see you at 8 p.m. in the evening tonight at 8 p.m. This is beautiful question, linked answer question. So this is another assignment question, question number 14 for the same linked question and question number 50. So that is all from my side. If anybody is having anything to ask, please do let me know. Otherwise, let me take your leave. See you at 8 p.m. and then again on Wednesday at 4 p.m. for the application of thermodynamics. All right. Thank you. Enjoy. Take care. Have a good night. Stay safe, stay motivated, and keep preparing for your upcoming examination. Thanks a lot. Jai Hind.